Well, guess what? It happened again. Ken always knows right when I'm videoing a lecture and calls. So he called again. So that's why we stopped. But that's okay. We were done with example 1. We can move on to example 1C. So a point is chosen randomly on AD. Find the probability of each event. So we're on example 1C on page 719. Okay, the point is on A, B, or CD. So we have 2 options now, okay? Our total is still the entire line, is the entire space we're talking about. So that's still going to be our 12. But this time we want to know the probability of it being on A, B, or CD. So what we're going to do is we're going to add those together. So AB is 4 and CD is 5. So the total for both of them added together, 4 and 5, A, B, or CD, is a total of 9. So when you have an or situation that you're looking at, you're going to add those things together, okay? So 9 over 12, of course, we want to reduce that. 3 goes into 9 3 times, 3 goes into 12 4 times, and so the probability would be 3/4. Okay, so if it's an or, add those together. Okay, we're skipping example 2. I usually do example 2 and do the problems, but they're super crazy complicated, and you're not here, unfortunately. So I'm going to not have you do them on your assignment either. The ones that go with example 2, I put it in your lesson planner. We're not going to do those. So we're just going to skip example 2. Let's move on to 3. Okay, 3 is the pie chart. Different colors have different degrees sections. So remember, in an entire circle, how many total degrees do we have for an entire circle? 360, right? So our total space, which is what goes on the bottom, our total space is the total degrees of a circle. Okay, so let's look at example 3A. The pointer landing on red. What's the probability that the pointer is going to land on red? Well, our entire space is 360 and red is 80. So that's just simply 80 over 360. And I would reduce, they did that for us, it's 2 ninths. So you're going to want to reduce to 2 ninths. Okay, let's try B. What is the probability that the pointer lands on purple or blue? Okay, remember, I said when we do or, what math thing do we do? We add, right? So or is adding. So purple is 75, blue is 60. We add those together, we get 135. So add the 2 things together that they're wanting you to talk about, okay? And when we reduce that, we get 3/8. I like these ones actually in example 3. They're not so bad. Okay, 3C, the pointer not landing on yellow. Okay, so we went everywhere but yellow, right? They do it a little weird. Oh no, actually that's the way I would do it too. Everywhere but yellow. So I take my entire circle, which is 360, subtract the yellow part, which is 100, because I don't want to do that part. And I'm left with 260, right? So that's 260, everything but yellow. And of course, we're going to reduce that, which they did for us, 13 over 18. Okay, so that's example number 3. All right, now let's move on to example number 4. I'm not going to do it on the board with you. I'm just going to kind of give you some instructions for it. I think this section won't be too bad for you guys. And if I just kind of get you going in the right direction, you'll know how to do example number 4. For example number 4, the first thing you need to do is get the area of everything. You need to get the area of the entire blue rectangle, which is 20 by 45. You need to get the area of the equilateral triangle. Okay, notice in the equilateral triangle, the apothem is 6. And a couple sections ago, we learned apothem times perimeter divided by 2. That's how you would get that area for that equilateral triangle, okay? Then you need the area of the circle, which has a radius of 6. And you would need the area of the trapezoid, which we've learned earlier, base 1 plus base 2 times height divided by 2. Okay, so get all of your areas first of all the shapes in the thing. Okay, so once you've done that, what you're going to want to do is, if it says, what is the probability that you will land on the equilateral triangle? You would take the area of the equilateral triangle, which they did for you using apothem times perimeter divided by 2, and they got 187. So then you take the area of the triangle, 187, and you put it over the area of the entire shape, which is that blue rectangle, which is 900. So get all of your areas first, then put the one they're asking about over the total shape, Okay, so B, the trapezoid. You just get the area of the trapezoid and put that over the entire shape, which is still 900, didn't change. Okay, so the circle, you do the area of the circle over the entire thing, which still is what? 900, okay? And then you just reduce. You can use decimals in this one if you need, it looks like. They just turned the fraction into a decimal, I think, to be able to make it a little bit easier. Okay, that's it. So you're not going to be doing number 7. You can do number 6. The probability will be no problem. It's number 7 that's crazy. So you're not doing number 7 or 21 or 22. But you can do 6 and 20. You should be able to do those, okay? All right? Okay, you guys. We'll talk to you later. Oh, I almost forgot. I almost forgot the joke. Question. 50% of the teacher's desk is covered with student exams. What is the probability of spilling coffee or Diet Coke on one of them? Well, this, you know what? This wouldn't work. It has to be coffee. 50% of the teacher's desk is covered with student exams. What is the probability of spilling coffee on one? Half and half. Okay. Goodbye.